Okay, we have 16 raised to the x minus 1 is equal to 64. So I could tackle this problem in a few ways, but the one way I want to try is I would like to equate the bases. Equate the bases. So on the left side here, I have base 16, and on the right side, this could be exponent 1, I have base 64. So my goal is to write the bases so they are the same. So here really we can have two choices. I can rewrite 16 as 2 to the 4. And I can also write 16 as 4 squared. Then I look at 64, and 64 can be written as 4 cubed, because 4 times 4 times 4 is 64. I can also write 64 as 2 to the 6th. So in this case, because I have these choices, I'm going to go ahead and choose base 4. So 16, I'm going to rewrite it as 4 squared. But I also have the exponent here, x minus 1. So I'm going to bring down that exponent, x minus 1. So really the only thing I changed, or it's not so much changed, but I rewrote 16 as 4 squared. Now I'm going to set that equal to, and I want to equate the bases. So I want to have the same base as I do on the left side. So I will rewrite 64 as 4 cubed. Now that I have my bases the same, I can drop my bases and equate my exponents. Okay, so I have 2 times x minus 1 is equal to 3. And from here, it's just a multi-step equation. So I will distribute the 2 to get 2x minus 2 is equal to 3. And then just add 2 on both sides. 2x, this will cancel, is equal to 5. Divide both sides by 2. And our answer is x equals to 5 over 2. Okay, try this one. All right, I have 32 to the x plus 1 is equal to 2. So I want to look at my bases on the left and on the right, and I notice that I have 32 and 2. So I don't have much of a choice here because this 2 here is pretty much fixed. So if I can write 32 with a base of 2, that's my goal. So again, we want to equate the bases. How can I rewrite 32 with a base of 2? Well, I know that 2 to the 5th is equal to 32. So I'm going to rewrite 32 as 2 to the 5th. So we remember that that's raised to the x plus 1, so I'm just going to rewrite it. X plus 1 is equal to 2. Now this 2 here, even though I don't have an exponent written, is actually raised to the 1. Now that my bases are alike, I can, first of all, we can distribute the exponents. So we have 2 to the 5x. Don't forget to distribute the 5 to the 1 plus 5 is equal to 2 to the 1. Okay, now that I have equated the bases, I am going to remember our property. If we have a base raised to some exponent is equal to the exact same base raised to a different exponent, then the only way that's true is if x equals y. Okay? So in this case, the only way this is true is if 5x plus 5 is equal to negative 1. All right, ignore this little, I don't know how that appeared, just ignore that little mark. Okay. So I'm going to rewrite my equation as 5x plus 5 equals 1. Now, the one thing I want to emphasize is this 1, what some of you did is you put a 0 instead of there. So be careful, when you have a number, it is raised to the 1. Okay? Not 0. All right, from here I'm going to solve for x, so subtract 5 on both sides. We'll cancel, and I'm left with 5x is equal to 1 minus 5 is negative 4. Divide both sides by 5, and x equals to negative 4 over 5. Okay, how about one more? Try this one. Okay, hopefully everyone chose base 5. So I have 125 on the left as my base, and on the right I have 25. So 125 I know can be written as 5 cubed, and 25 can be written as 5 squared. So I'm going to take 125 and write it as 5 cubed. Now don't forget our exponent, x plus 1, so I will rewrite x plus 1 is equal to, rewrite 25 as 5 squared. And I have my x here, so I will rewrite the x. Now I'm going to distribute my exponents. So I have 5 raised to the 3x. Don't forget to multiply the 3 times the 1. Plus 3 is equal to 5 to the 2x. Once my bases are the same, I can equate the exponents. So rewriting that, I will have 3x plus 3 is equal to 2x. Subtract 2x on both sides. I will have 0 here on the right and x plus 3 on the left. Subtract 3, and we have x equals to negative 3. Hopefully everyone got negative 3.